Hello guys, you are welcome to today's class. This is Chemistry Hangout, and if you are just watching this YouTube channel for the very first time, I want you to subscribe to this channel and turn on the notification bell so that when I upload any video, you are going to be notified. For the Waec this year, it's going to be wonderful, it's going to be awesome, it's going to be fantastic. You know, the exam this year, the practical this year, is one of the practical I love so much. I'll be receiving a lot of questions, and for today, please, I want you to pay maximum attention. I'm going to be giving instructions, humbly giving instructions to my co-educators, though that is my opinion, but I believe the information is going to help us. So if you're a chemistry instructor or you are actually preparing students for Waec, chemistry Waec practical this year, then please pay maximum attention to this very particular video. And definitely, if you are a student, you are writing Waec this year, you are a science student specifically, you are writing Waec this year, definitely you should pay attention to this video. At the end of this video, I'm going to be giving out an instructions, and don't forget, I promised the Waec student that I'm going to be creating a group. You know, what we are just trying to do is to make sure these people come out in flying colors. We did that for JAM, and you know, thank God, I've been receiving a lot of messages as regards the awesome result. There are some of the students that we are opportune or privileged to actually coach. Some of the result has been coming to my DM. I will share some maybe later, but I'm going to be giving instructions for Waec students too. We are going to help you not only even in chemistry, we are going to help you with physics. Just do all our possible best to make sure that you actually come out in flying colors. So pay attention to this video. I'm going to be giving out instructions. I'm going to be analyzing. I'm going to be answering questions. Yeah, I'm going to be answering questions for this very particular practical. So if you're online now and you're watching me, you can put your questions in the comment box section. I will answer because it's a live video. Okay, so, and if I did not answer your question, because I have some questions that they have already asked me that I will answer in this video, and if your question is not part of that question, you can ask me in the comment box section, then I'm going to reply you as fast as possible. It's going to be wonderful, it's going to be really wonderful, and I want us to pay maximum attention. So today we are going to look at the general view of how the Waec 2024 will be. What are we expecting? Okay, what do we need to do as chemistry educators that are preparing students for this exam? What do we need to do, okay, on our own part? For student too, what do you need to do? Because for you to be successful in this year exam, the teacher has their role to play, and definitely the student too has their role to play. So today I'm going to be giving instructions to chemistry instructors to help them, you know, so that they can guide the students well. And for students too, I'm going to be giving you a lot of instructions that will help you for this year exam. So what do we have for this year? The instruction is actually out. Let me show it on the screen. This is the instruction for this year. You can see that on the screen, okay? This is the instruction for 2024 Waec practical. And if you check the instruction that you have there, you're going to be seeing permanganate solution, that's KMNO4, okay? Permanganate, that's potassium permanganate, that's KMNO4. And you're going to be seeing iron 2 sulfate, that's FeSO4. If you look at that very particular instructions, there is a particular measurement. Let me talk to teachers now. There is a particular measurement you have to measure there. If you look at that very well, I think for permanganate, if you check that, you have 1.58 according to the instruction there. You see they said 1.58 gram in 1 dm cube of the solution. And for iron 2 sulfate 2, you have the mass there. I want to believe that as teachers, we know how to prepare this. It's a very simple preparation anyway. But if you still have challenges as regards the preparation, you can reach out to me. The aim is to, you know, work together, make us better so that we can actually lead these students to success. So that is what is there. So very important, the titration this year is permanganate solution, and you have iron 2 sulfate. Okay, let's go to the analysis now. Let's go to the analysis. Having known that, let's go to the, so let's say 2024 chemistry Waec practical analysis. Waec practical. So what's the analysis like? So for what they actually gave us, you see that we have K MnO4 solution, and we have the iron 2 sulfate. The mass concentration is there, so I want to believe these are in solid form. KMnO4 is in solid form, iron 2 sulfate 2 is in solid form. So very, very important. Now let me start by answering this question. Please, there is difference between the hydrated iron 2 sulfate and the hydrous iron 2 sulfate. You know, one of the way to actually make this student pass starts from us, because the instruction, that's why they said it is an instruction. So we have to adhere strictly to the instruction. Some people have asked me that, sir, can we use this? I have this in my lab. Can we use this? You cannot use this, sir. The instruction in what they have given us is that we use this. There is a difference between this and this, definitely, because their relative molecular mass is different. And if you are using this now, it will not affect, you know, the values we are supposed to get. So please, we are using iron 2 sulfate, hydrous, not hydrated. So for this, that's the first question I'm answering. Don't use this, please. Don't use the hydrated. Don't either it is hexahydrate, either it is pentahydrate, any hydrated iron 2 sulfate. Don't use it. We are using the hydrous as given in the instruction. I want to believe that is clear. So after we have prepared this, I think what we have here is around 1.58 gram, and this is like 5.5, if I'm not mistaken. Okay, so after we have prepared this now, okay, we have prepared this. Don't forget I said the titration. So for the number one now, the titration is a redox titration. Is a redox titration. And you know, under the redox titration, some people will call it permanganometric titration. Yeah. So under the redox titration, some people call it permanganometric titration. And when you hear the word permanganometric titration, you know from the word permanganate. Okay? From this very particular one, that's where they brought this from. So, which means the permanganometric titration involves a kind of titration in redox where we actually use KMnO4. So note this, KMnO4 is the permanganometric titration. That's why we are saying it's an example, but you know a lot of people know it as redox titration. That's not a problem. Now, take note of this now. Your KMnO4 here is acting as the oxidizing agent, because you know in redox, the meaning of redox is reducing, oxidizing, or reduction, oxidation. Just a short form of reduction, oxidation. You get that now? So the short form is redox. So which means it's a reduction, oxidation. And very important, if you know the word reduction, oxidation, you should know we have reducing agent, we have oxidizing agent. So in this very particular titration, your KMnO4 will be acting as the oxidizing agent, while iron 2 sulfate will be acting as the reducing agent. I want to believe that is clear. So which means that our KMnO4 is purple in color. Our KMnO4 is purple in color, and our iron 2 sulfate is around green in color. It's around green in color. If I'm not mistaken, it's around green in color. Okay, so how do we carry out this titration? Remember that in our normal acid-base titration, the acid is going to be in the burette, okay? While we are going to pipette our base, which will be in the conical flask. But for our, you know, our redox titration, which involves this, our KMnO4 now, our KMnO4 will be in the burette. This will be in the burette. Our purple KMnO4 will be in the burette, while our iron 2 sulfate will be the one we are going to actually pipette, that will be in the conical flask. I want to believe this is clear. So with this now, what will happen? The equation of this reaction, the equation of the reaction is going to look like this. The equation of the reaction is going to look like this. You know, we have MnO4 minus, okay? Then we have plus iron 2, okay? Then we are going to have 8 hydrogen ion. I'm going to explain why that is like that. Then we have Mn2 plus iron 3 then we now have 4H2O. So this is how the equation will look like. Let's see if the equation is balanced. Manganese is 1, manganese is 1, is balanced. Oxygen is 4, oxygen is 4, is balanced. Iron is 1 here, iron is 1 here, balanced. Then we have 8 hydrogen, then we have 8 hydrogen, balanced now. You know, if you don't know how to balance redox equation, I have a video on my channel that talks about oxidation, reduction, okay? Everything about oxidation and reduction is there. The balancing of the equation, everything is there. Now look at this. Let's see, is this equation MnO4. So I should have this, very important, because it will be in the ratio 1 to 5. If we finish balancing it, very important. So 5 this, 5 this. You know, I did not actually write the steps. That's why some might be actually confused, okay? But you can check my channel. There is a video that talks about all this, how we actually got this very particular equation. You're going to see there. So if you look at this, the manganese here is ratio 1 to 5. You can see that is ratio 1 to 5. So which means that your manganese is reducing from 7. If you calculate the oxidation number of manganese here, it's going to be plus 7 to plus 2. Definitely, that is a reduction. While iron is changing from plus 2 to plus 3. That's what oxidation. So if you balance it and you follow all steps, you're going to get this. Now, very important, this is what I want to bring out now. If you look at this, I have 8 hydrogen ion here. Why did I have that? If you remember balancing of redox equation, we have balancing in the acidic medium. We can balance in the acidic medium and we can balance in the alkaline medium. I want to believe this is clear. So, which means that in this kind of case, the way we balance is the acidic medium, because you already know the definition of an acid. A substance that will produce hydrogen ion or hydrozonium ion as its only positive ion when dissolved in water. So the presence of hydrogen ion means that, please, chemistry instructor, take note, which means that before I actually titrate this, I am going to acidify the iron 2 sulfate. Because the reason why we acidify the iron 2 sulfate is to provide an acidic environment for the reaction to actually proceed and get to completion. I want to believe that is clear. So for FeSO4, immediately I have, pipetted 25 centimeter cube of FeSO4. For chemistry instructors now, you're not going to prepare 2 molar H2SO4. Prepare 2 molar H2SO4. So if you have prepared 2 molar H2SO4, I believe we should know how to do this as chemistry instructors. If you don't know how to do it, please you can reach out to me. I cannot be doing all those explanations here now. So prepare 2 molar H2SO4. So the 2 molar H2SO4, measure around 5 centimeter cube of it. Okay? Measure around 5 centimeter cube of 2 molar H2SO4 and add it into the conical flask that already have this. I don't know if you guys are getting what I'm saying. Which means that for this reaction to proceed, we need an acidic medium for it to actually proceed. I want to believe that is clear. So for us to provide this very particular titration with the acidic medium or the acidic environment that it needs to proceed, then I'll prepare 2 molar H2SO4. So immediately I pipette my FeSO4, I measure 25 centimeter cube of iron 2 sulfate in the conical flask. Then I will add 2 molar H2SO4, 5 centimeter cube. So 5 centimeter cube of 2 molar H2SO4. I will add it into the conical flask that already has this. Then I'll begin to titrate. So when I begin to titrate, it will get to a point, our end point should be pink or pale pink. The first permanent pink or pale pink is where this reaction has actually got completed. I want to believe this is clear. Now, from this, one of the questions we can be asked is that when we want to acidify our iron 2 sulfate, why did we use H2SO4? Because why are we not using ACl? Very important. HCl2 is an acid. Why are we not acidifying with ACl? These are questions that can be asked, maybe because your number 3 questions are basic. I'm talking to students now. Your number 3 questions are basic chemistry questions, okay? And they can ask it from theory of practicals. So why is it that we added H2SO4 and we did not add ACl? The reason is because if we acidify with ACl, ACl will react with KMnO4 to liberate chlorine gas. And immediately ACl reacts with KMnO4 to liberate chlorine gas. It means that our titration will not be accurate. So the reason why we are not using ACl is because ACl will react with what? With KMnO4 to liberate chlorine gas. So we cannot use ACl. Do you see? The reason why we are not using H2SO4 is because H2SO4 will not react with what? With KMnO4. That's why we are using this. So you might be asked, why are we using H2SO4 to acidify? The answer will now be because H2SO4 will not react with what? With the KMnO4 to form anything. It will not react. I hope that is clear. But why are we not using ACl? Then you told them it's because ACl is going to react with KMnO4 to liberate chlorine gas. I want to believe that is clear. Another question that we can be asked, please take note of this. I'm just giving procedures now. We are going to do the titration by God's grace on this channel, but I'm just giving this so that we know what to expect, and for chemistry educators, you know what to prepare. So, very important, this, don't forget, this is in the burette, this is in the conical flask. After measuring 25 centimeter cube of this, okay, in the conical flask, we now add 5 centimeter cube of, let me remove this here so that you don't think it's HCl. So 5 centimeter cube of 2 molar H2SO4 to this very particular one, then we begin to titrate. So as we begin to release the permanganate into the conical flask that has this, then we are going to be looking for an end point that is either a pink or a pale pink. At that point is where the redox titration has taken place, the reaction has gotten to completion. Okay, so we need to stop it. Now, another question we can be asked from theory of pre-practical is that why is it that, because in your burette now, don't forget your KMnO4 is purple, which means it is colored. Do you see that now? They can ask 2 questions from here. And one of the questions is they can ask that why is it that there is no indicator? Because in acid-base titration, don't forget, we are using indicator either methyl orange or phenolphthalein. Is that not true? Definitely. But here, why is it that we are not using indicator? Because if you look at the way I was explaining, you see, I said you carry out the titration and we are looking for what? A pale pink or pink. So there is no indicator. Why? The reason is because, why is there no indicator? The reason is because KMnO4 is self-indicating. What do I mean by self-indicating? Self-indicating means KMnO4 is already colored. Have you forgotten? KMnO4 is already colored. And we have said that our KMnO4 is purple, our FeSO4 is green. Definitely, if this changes, we will know. Because KMnO4 is colored already. So KMnO4 is an indicator on its own. So you can be asked, why is it that there is no indicator? The reason is because KMnO4 is self-indicating. I want to believe that's clear. Another question you can be asked in this is because when you are now reading the burette, when you are reading the burette in titrations that involve KMnO4, we don't take the lower meniscus. We take the upper meniscus. The reason why they are taking that, they might ask you, why is the upper meniscus red in KMnO4 titration? You can be asked. The reason is because KMnO4 is colored. So because it is colored, you will not be able to see the lower meniscus. Do you get that now? You will not be able to see the lower meniscus. So that's why you read the upper meniscus, because that's the one you can see and you can read, because it is colored. Do you see that now? So these are questions that can come from there. So KMnO4 is self-indicating. I've said that. And why is it that you don't read the lower meniscus or the lower rim in the burette when you are titrating? Is because KMnO4 is colored, so we will not be able to see the lower meniscus of the burette. We will not see it because it's colored. So we have to take readings from where we are actually seeing, which is the upper meniscus. I want to believe that's clear. So you run this maybe 3 or 4 times. You know your rough first, second, third, or you will do rough first and second. I want to believe that is clear. Then you now prepare your table. Now, how will your table look like? Don't forget that our table will look like this. Our table will look like this, burette readings. Then we have initial readings. I will explain something here. Final readings, I will explain something here, so I want us to pay attention. Final readings, initial readings. Okay? So from there, very important, our unit is very important in centimeter cube. Then I can have my rough, very important in centimeter cube. I can have my first in what? In centimeter cube. I can have my second in centimeter cube, and I can have my third in centimeter cube. I want to believe this is clear. Please make sure you tabulate your readings. That's why they said it's a table. So we tabulate our readings. Do tabulation, very important. Tabulate, And don't forget, here now, for acid-base titration, we always write volume of acid used. But here now, we are not using an acid. So what we need to write is volume of KMNO4 used. Why are we writing it like that? Because it is KMNO4 now that will be in the bullet. I want to believe that is clear. So from there, we now have this. Then we can now close our table. Okay. Don't forget that on top of our table, we always write volume of pipette. Do you get that now? Or volume of base. So we can write volume, or because we don't have base here now, we have FeSO4. So the volume we are using most times in most schools, because you have 20 centimeter cube pipette, you have 25 centimeter cube. But in most schools, it is 25. However, check the volume of your pipette in your school to know the volume. It can be 25, it can be 20, but in most schools, I know it's always 25. So this is how your table will look like. Now listen, I want to explain something, because as a student too, you have to be very smart. Yes, you have to be very, very smart. I will explain something here. We have two cases here. Let me say this categorically and emphatically. And that's why I said what I am doing is a general analysis. Number one, we will have students that their school is not approved. Do you see that? That the school need to register them in another school. Is that not true? Very true. So, which means that, please pay attention to this. If your school is not approved and they need to take you to another school to write the exam, you have already done the practical in your school, you got a particular title, please make sure that you listen to the chemistry teacher in that school that they are taking you to. Of course, your chemistry teacher might be right, but you will get there and the chemistry teacher there will tell you, this is not the title value. This is the title value we are using here. Please abide by the instruction of the chemistry teacher in the school you are writing this exam. For students now, I'm saying this categorically, because some of you begin to call your friends, what's the title value in your school? What's the title value in your school? The title value in my school is this, so I don't even know what is wrong with our chemistry teacher. You are very wrong, because there is an instruction, there is a report the teacher in that school will fill. I've said that. If you go and watch one of my videos that I shared, that how to get A1 in chemistry, please make sure you follow the title value in that school. If your title value is different from the one in that school, it will be a problem. I hope that is clear. So in any school you are, maybe you are going to another school, maybe it is in your school, listen to the instruction of the chemistry teacher. I hope I am clear here. Now listen, even if I do the practical here on this channel and I got a particular value, okay, and you went to your school and you get another value, don't use my value here, because I am not the teacher in your school. It is the teacher in your school that is going to fill a report, not me. I want to believe this is clear. So please, students, obey the instruction in your school. I'm saying this and I'm emphasizing on it. Know the title value they are using there. Probably the teacher might be lenient to tell you the range of the title value. Very important. Or you are asked to carry out the titration yourself. So we are going to be doing two things. We still carry out the titration here on the channel to get our own title value, so that you see how you will do it on that day. And very important again, now look at me. Let's take for example, you go to your center and your teacher now told you, I am telling you how to do a smart move now. I want to believe you are paying attention. This is a smart move. Let's say for example, I'm a student and I got to my school and the teacher already told me the range of the title value, which some teacher might be lenient to do. They can. Okay, let's say for example, the teacher told you that the title value here is around, the range is around 20.20 centimeter cube. This is what the teacher gave you as the range. Now listen to me. Listen to me now. This is the range the teacher gave you. If the teacher has given you your range, I'm talking to students now. The teacher has given you your range, you can do a smart move here. Ow, look at me. This is what the teacher has given me. I need to be very smart. I might not titrate. Yes, that's just a smart move. I call it a smart move. I might not actually titrate. I can prepare my table in such a way to agree with the title value the teacher has given me. So instead of me stressing myself, one of the way the teacher can can help me ease the stress of the exam is to give me the range. If your teacher did not give you the range, don't assume the title value. Carry out the titration. We are going to show that on this channel. But if your teacher is lenient enough to give you the range of the title value, then you can work with this. How do you do that? Look at this. Don't stress yourself. Don't stress yourself. Just come to your initial. 0.00, 0.00, 0.00. I want to believe this is clear. The 0.00 means for all the titration you carried out, you refilled. I want to believe this is clear. You refilled. Then look at me, please. Look at the title value the teacher gave me. I will now say, okay, let me increase for my rough. Let me increase this title value by around 0.40. Do you see that? So I'll just say 0.40 to this. So that will be 20.60. Do you see that? So I will say my rough is 20.60. I want to believe somebody is here. The title value the teacher gave me becomes my first, 20.20. I will add 0.1 to this, 0.01 to this, 20.30. Then I will write again 20.20. This is my table. Very smart move. Then I'll come here and say 20.60, 20.20, 20.30, 20.20. My table is ready. I don't need to titrate again. My table is ready. Because the reason why you are titrating is because of this thing. This very particular title value is why you are stressing yourself. Titrating, point KMNO4, looking for pale pink. But if you want it to be easier so that you can be, can ease your stress, then you don't need this. You can do this. I don't know if this is clear. Another person can say, this is for one person. You have to be smart. Just understand this. Another person can say, okay, my own rough is 20.50. After I've written 0.00, my own rough is 20.50. So another person can say, okay, my first is 20.30. My second is 20.30. My third is 20.20. Can you see? This range and this range and this range will still give you the same thing. I will still use my calculator to get the average. Another person can say, oh, this is my own rough. My first is 20.10. My second is 20.20. My third is 20.20. If you look at what I am doing here, the rough might beat a bit high. Why? Because I know I'm not using it. Most times they don't use rough. Though you can use it, but if it is very high, you don't use it. So, and if you look at my first, second term, you can see the closeness between them. The difference between them is around, look at this. If I minus 20.20 and 20.10, you can see this will be 0.10 difference. So look at this. Between this and this is the same. Then between this and this is 0.1. This and this is the same. Between this and this is 0.1. Can you see that now? This and this is the same. Between this and this is 0.1. I know what I'm doing. So the difference between the ones I want to use is not more than 0.1. So that I can still arrive at my teacher's range. I want to believe this is clear. So the reason why you are carrying out the titration is this. This is the reason why you are carrying the titration. This is the reason why you are carrying the titration. So, but for some smart students, so you can use this, but some smart students, look at something. For some smart students that want to actually look different, I can say, okay, sir, my rough is 20.60. Just an assumption. 20.60. My initial, look at it, my initial is 0.00. Do you see that now? I will not say this is now my rough. Get this. So you can use any one. That's how I'm explaining. So my first now, a lot of people will write 0.00 as their initial. I will now say no. My own first, the initial is 20.60. The reason why I've done that, what I'm telling the supervisor is that when I did this rough titration, I did not refill. That's why I started from this. So since I know what to write, look at what I'm doing. You can see this person's own, this 20.20. I will now add it to this. So when I add 20.20 to this, because this is what I want to use, I already know what I want to use, would have, spell it out. I'm using 20.2 as first, I'm using 20.3 as second, I'm using 20.20 as third. Do you see that? So this one, and this is what I'm using as first. So I will add it to this. So when I add 20.60 to 20.20, that will give me 40.80. Do you see that now? So this one now, I'll write 40.80. This is a smart move. This is another smart move, just to look different. So you can pick any of the format I'm giving you. This is second. Now, I cannot come and write my initial as 40.80. You know why? Because the volume of the burette is 50 centimeter cube. Do you see that? So if I write 40 here, the volume of the burette will exceed, which will be wrong. So I already know that 40.80 is already getting closer to 50. So what do? I'll tell them that my initial again is 0.00. What's the meaning of that? I refilled again. I don't know if somebody is getting me. So then I'll say, okay, since I refilled again, what did I want to use as my second? 20.30. I add it to this. Give me 20.30. I don't know if somebody is still getting me. So I'll now say, okay, for my third now, you can see, for my third now, 20.30 will now be what? The initial. I'll now add 20.30 to this. So if I add 20.30 to this, that will give me 40.50. I'll now have 40.50. I don't know if somebody is getting me. So at the end of the day, if I want to get the volume of this, let's look at what this will be. So if I subtract, because I will subtract, then this will be 20.60. This one will now be what? If we minus this will be what? 20.20. This is that. This will be 20.30. Then this will be what? 20.20. Can you see this value and this value is the same? But our table is what? Is different. If you don't understand this, you need to watch this video over and over again. If you don't understand this, I want to believe you should understand this, where you have all the initials to be 0. If you don't understand this, you should understand this. So I have given 1, I gave another 2, I gave 3, and I gave 4. So I gave 4 ways of how to, how to arrange your table in such a way that it will ease your burden, if and only if your teacher has given you what? The range. I want to believe this is clear. This is a smart move. You need to understand. So if your teacher has given you the range, you can do your table like this. Get me so that I will use that as calculator, so that you see. So let's look at the range. Let's look at the range. Let me use my calculator here from my phone now. Look at this. So let's look at the 4 table we actually had to, use our smart move. So we want to calculate volume of KMNO4 for the first one. Volume of KMNO4 for the first one. So we are using this divided by 3. Abi? So we are using 20.20 plus 20.30 plus 20.20 divided by 3. So let's see what our answer is going to look like. 20.20 plus 20.30 plus 20.20 divided by 3. So this gave us, so the volume here is 20.23 centimeter cube. And what was the value your teacher gave you? 20.20. Can you see you are within the range of your teacher's value? You might not get the same thing with him, but you will be very close to his range. I don't know if you are getting that. So this is the first one. The second one, we use this. So that's 20.30 plus 20.30 plus 20.20 divided by 3. Let's see what, if another person is using the same table. Let's see what we are going to get. 20.30 plus 20.30 plus 20.20 divided by 3. So this is 20.27 centimeter cube. You can see this is the second person. The third person, let's see, 20.10 plus 20.20 plus 20.20 divided by what? 3. So let's see what this one is going to be. 20.10 plus 20.20 plus 20.20 divided by 3. This one is 20.1, approximately 7 centimeter cube. Can you see our value? Because if we do this third one, it's still the same thing as the first one. We are just trying to, to play with our table, but we are still going to have the same values. I don't know if that's clear. So if you use this, you are correct. If you use this, you are correct. If you use this, you are correct. And this is your teacher's title. It will be very close to your teacher's value. I want to believe this is clear. So you need to go over this over and over again. So I just did this for students that are asking me questions that, sir, is there a way to do a smart move on our table to make sure that, you know, it is very, very accurate and it is closer to our teacher's title value if our teacher is lenient enough to give us the title value? I think I have done justice to that. You can do your table like this. So this will now be the average volume. It will not be volume now because it's now average, not divided by 3. So this will now be average volume of KMNO4 used. So average volume like that. You get it. I don't know if that's clear. So for our titrations, these are what we need to know. And this for students anyway. Now for my core chemistry educators, there's always conflict of interest when it comes to title value. It happened last year. If your school is approved and you are the teacher in charge of that school, please, if you have done practical with the student and you have gotten your own range, don't come on the day and say the title value is not it again. I remember last year, because Waec actually, you know, they had to twist the question. You don't work your title value to agree to the question that they are asking you. They have already given us a specification. I remember last year, they gave us a specification. We have already prepared it. And you know, a lot of people were calling and saying, no, we need to work it out to make it 2:1. I said, I don't understand this. Please let us be fair. Because when students in an approved school, when you have carried out titration with your student, you have concluded on the title value with them, on that day you are now saying the title value is not it. You know, it doesn't look professional. So please, for teachers, I want to beg us, let's do our work, do the practical, try to do practical with the students, conclude on the title value we are using on that day, probably if you are permitted to tell them, you know, conclude on what you are using by that day, and on that day let us use that same title value. So don't let us always look for title value to suit the question. It shows that we have not really done our job as teachers. So please, very, very important, do pre-practical with the student, show them how this thing is going to look like, and you know your title value already, let them practice too. You already have that. That's the reason why you are there as the instructor. You do the practical yourself, get your title, instruct them on what to do, and let them do the titration, and you see their value. If there is a much gap in their value, you correct them. Oh no, this is how you need to do it. Then you do it for them, so that at the end of the day, if you are not exposing them to your title value, on that day they are going to get a similar value to you. So please don't let us come on that day as chemistry teachers and say the title value is changing. What is changing the title value? Is it not the same preparation that you have done they are using? Okay, so it means something is wrong. So please, I beg us, let us adhere to our title value. You are working in an approved school, you are a chemistry instructor. Teach these children, let them, show them how to get title value that is closer to your own. Teach them how to do it. Do it first, let them see it, then now give them to do it. That's how to instruct practical. You do it yourself first, let them see the way you are doing it, then let them do others themselves, so that they will now see that, oh, what our teacher did and what we have done is actually, and that's how I carry out my practical. I do it in presence of the student. They will be gathered. I carry out the titration in front of them so that they will see it, and I will get my title value. Then I'll tell them to do it. So there is no way they are not going to get a similar title value to my own on that day, even if I am not exposing them to my title value. I don't know if you are getting that. So please, let's do our work, please. And for students that you are going to another school, obey the chemistry teacher there. I'm drawing my ears now. I'm drawing it for you people. I know students, sometimes you want to prove that you are smarter. Obey the teacher there. The teacher there has the final say. He's going to record the title value he has in the confidential report, and he's going to submit it. And if the teacher is lenient to have given you the range, I want to believe you know what to do for number one. Conclusively for number one, very, very important. Conclusively for the number one, I beg you students, if you have not watched the video, my last video on how to get A1 in chemistry, I have explained a lot of things there. I explained using the Waec marking gap, telling you where you can lost mark, where you can get more mark, what can actually make them to reduce your mark, and the rest like that. So please go and watch that video so that you can bring that here and you understand how all this thing is actually done. So very, very important. So please, for the titration, these are what we are expecting. We are still going to do the titration. I think I've said that. We are still going to do it on this channel. I'm just giving a general review of what we are expecting, what to do as teachers, and what we need to do as students. So please, let us prepare this reagent as teachers, prepare it, titrate it, you know, practice with the students, let them know how it is done. If they get it wrong, tell them why they are getting it wrong, so that it build up their confidence. It build up their confidence, so they will know if they have done it in class and they got the title value that is closer to your own, because you are monitoring them. They will have that confidence on the day of the exam that, oh no, we have done this thing before and we got title value closer to the one our teacher got. Oh, we are going to get it. Give them this self-confidence, and it will actually help them. So that's what we are expecting for our titration. I'm going to come out with my predicted question, and I'm telling you, it's going to be, I'm sure it is going to be 75% correct. That's the assurance. You should trust me on this channel. I'm coming out with the titration and the deduced question for number 1. So this is how it's going to look like. This is what you can do as students. This is what you can do as teachers. I want to believe this is very, very clear. So I have covered how the practical is going to look like. I've covered that. I've spoken to students on what to do. Okay, spoken to you guys on what to do. Okay, let me quickly chip in this. Now look at this. For probably you are using this formula on that day. You can still use this. So it depends. You know, it depends on you. You can see people used to think this is for, you know, acid. It's not for acid, because on that day they might say A is a solution of KMNO4. Very important. B is this. So A here can still be the A here. I want to believe that is clear. Why B here can still be the B here. But I've seen some people that they write something like this: OA, VOA, CRA, VRA, NOA, and NRA. Other, if you are not very careful, you are going to confuse yourself if you are not versed with oxidation, because here now you now need to know which one is the oxidizing agent and which one is the reducing agent. You don't need to disturb yourself. A and B. A, B can be B, because if you don't know this one now, you might be, you might be using the one that is reducing agent for oxidizing agent. So for me, I still prefer you go with the. If there is need for you to use this, I still prefer you go with this, because the A can still be A, the B can still be B, and you're going to get your answer. I want to believe this is clear. So that's that for number 1. That's that for number 1. Very clear. I want to believe this is very clear. I have done a lot of things here. I have given you some questions you can be asked. It's my own humble opinion. You can be asked, why is KMNO, why is there no indicator there? It's self-indicating. Okay, you can be asked, why do you use H2SO4 and not ACl? Said because ACl will react with KMNO4 to liberate chlorine gas. I think we have said that on this channel. I'm just trying to do some recap. So you can ask your questions. This is a live teaching. You can ask your questions as per titration. I will see how I can actually answer that. And we have talked about why we read the upper ring or the upper meniscus. Or let me use the word upper rim anymore. Can use upper rim, upper meniscus in the burette. The reason is because the upper meniscus or the rim can be seen and read. We are not using the lower rim or the lower meniscus in the burette, because that one cannot be seen and cannot be read, because KMNO4 is actually correct. So, guys, this is that for. I'm still coming with my predicted question for titration. I'm still coming with my predicted question for qualitative analysis, but I just have to do this so that we, for teachers, I want to believe you should know how to prepare this. If you don't actually know that, you can reach out to me. You should know how to prepare this. You should know how to prepare this. Okay, 2 molar H2SO4 and how the reaction will go, how the titration will go. We should know how to do that. Okay, very important. Let me answer this question. In the confidential report that they gave us, or the instruction to school that they gave us, let me put it again. If you look at it now, you will see a lot of reagents there. These are customary. Customary means that's how they bring it every year. For some people that have been asking me, sir, I am a new chemistry teacher, does it mean that I'm going to buy all this? No, you're not going to buy it. You are only going to buy the one you know is significant to the practical we want to do. For the instructions, you see a lot of reagents there. There is methyl orange, there is phenolphthalein, there is silver nitrate, there is potassium dichromate. All these ones, you might not use them for any test for this year. So you as teachers are the one that will now select the few that will be beneficial or that will be significant to the practical we want to carry out. Okay, so like silver nitrate, I'm not sure we're going to use silver nitrate this year. It's in the instruction, but we're not going to use it. Potassium dichromate is not significant to the test that we are giving. Methyl orange is not significant. Phenolphthalein is not significant. You know all these things. So please, you are the one that will select you. You can still reach out to me so that we can just, we can look at, okay, this one you buy, this one you will not buy, so that you don't just waste money buying all the reagents. So we are just going to select few reagents that will be significant, okay, that is actually related to the test we want to carry, and that's that. So guys, very important, let me wrap this off. So very important about the titration. I think I've made some points here. If you have been following me for today's class, I made some points here. So if you need to write anything here, that's why I'm not rubbing this off now. If you need to write anything here, you can write. So let's move to the number 2, which is the qualitative analysis. Please, I want us to pay attention to this. Don't forget, I said I'm still coming with my prediction of how it is going to look like. It's my prediction. I'm still coming, but I need to do this so that to guide my co-educators and the students on what to do, what to expect, how to go about it. I want to believe the titration is clear. So that's what we are expecting. Don't forget, I'm still coming with my prediction for the titration, the question, and how to solve it. This is just showing us how to prepare the reagents, what are the things we need to do, what are the things to expect, all sorted. So for the qualitative analysis, we are giving 2 inorganic salts. Okay, we are giving lead. We are giving lead nitrate, and we are giving sodium carbonate. These are the 2 salts that we are giving. Please, I want us to pay attention to this. And I will show just simple thing here. I will show just 1 or 2 things. Though I've not prepared my sodium hydroxide, I've not prepared my bench reagent, sodium hydroxide. I don't have anyone again. I would have even done the qualitative analysis, but I can't do that now because I need to prepare my sodium hydroxide, prepare ammonia, because we're going to be using them and I don't have them here. So, but I have my lead nitrate, definitely. This is my lead nitrate. If you look at that, this is my lead nitrate, okay? This is my lead nitrate, this is my sodium carbonate. So I have the salt. They have supplied me with the salt for this. They supplied me earlier. So I expect the qualitative analysis very soon. So now, what are we going to note here, or what should we expect here? Please pay attention to this. Pay attention to this. Follow me here now. What are we expecting here? Now, for lead nitrate salt, this salt is soluble in water. This salt is soluble in water, and this one too is soluble in water. I want to believe this is clear. So, but in the instruction for chemistry educators, they said 1 spatula full of this and this mixed together. Do you see that now? 1 spatula full of this and this mixed together. If you mix this and this together, okay, they will now ask them to put 10 centimeter cube of distilled water. Now look at what will happen. A double decomposition will happen here when you mix these 2 together and you add water, which is definitely what they are telling us, what they will ask us to do, because they have told us in the instruction that we should mix these 2 salts together. So you are testing for these 2 salts that is mixed together. We should understand one of the way to prepare an insoluble salt is double decomposition. We have 2 ways: double decomposition and direct combination of constituent elements. So if I mix these 2 together, look at that now. If I mix these 2 together, PbNO3 2, okay, 2 here, plus this, immediately I put water, there will be double decomposition. And what will happen, I will now have this lead carbonate like this and sodium nitrate. Let's balance the equation. 2 sodium here, let's put 2 here. Let's see if the equation is balanced. I love to balance the equation so this is lead, balance. Nitrogen here is 2, nitrogen here is 2, balance. Oxygen here is how many? Oxygen here is 6 plus 3, that's 9. Oxygen here is 3 plus 6, that's 9 also. Sodium is 2, sodium is 2. Then this is balanced now. Do you see that now? So which means now, look at this. If they now ask us, we have mixed these 2 together by the instruction they have given us. We have mixed these 2 together. So immediately we add water. What will happen? This will be formed by double decomposition, and this is an insoluble salt. lead carbonate is insoluble salt, while this one is what is soluble salt. This is where the test will now start from. This is that now. So, which means that if I have, immediately I mix these two together and I add water, this will be formed, this will be formed. They will now tell me to filter. These are what we are expecting. They will not tell us to filter. So if I have something like this, just an example, I have my filter paper like this. You get that now? So which means if I pour this on a filter paper and into this place, then I will have the lead carbonate as the residue, and I will have my sodium nitrate as the what? The filtrate. Do you see that now? So what we are testing for now will now be this and what? And this. I want to believe this is clear. So very important, when we mix with water, when we mix with water, we are going to have this as insoluble, this will be what? This will be soluble. So from there we can have filter. So if we filter, the residue, that means the one that will be on top of the filter paper will be lead carbonate, because that one is insoluble. Why? Sodium nitrate is going to be the filtrate. It will penetrate the filter paper. And that's the reason why I said one of the ways to produce insoluble salt is by mixing two soluble salts. Do you see that now? This is soluble, this is soluble. As we mix it together and we add water, what happens? Insoluble salt is formed. See, all this practical, we should understand that all these practicals are our rudiment chemistry. Yes, they are our rudiment chemistry. So they are testing us based on the theory of chemistry that we know, and that's how the practical they are giving us. So in fact, this topic is an elementary topic in chemistry, acid, base, and salt. So these are preparation of salt. So from here now, what are we going to expect? Let's talk about, which one should we talk about first? Let me talk about the sodium nitrate first, then I'll finish up with this. So for the filtrate now, which is what? Sodium nitrate. What are we expecting here? Number one, I am not expecting them to tell you to test for sodium. That's my assumption, and I think it should be 95% true, because if they want to test for sodium ion, they might not have told us to mix it together, because I've even done that last year. If you're going to check the NECO video last year, golden flame sodium, we did it last year if you remember. So if they ask you to test for it, we have done that before. So know that if they ask you to test for this, that means maybe they'll ask you to dip the spatula in this sodium nitrate and put and eat it. You will see the golden flame, but I'm not expecting this. That's my prediction. But I'm saying if you see it, you should know it. So what I am saying here is actually two for this. They can ask us to eat this sodium nitrate. They can ask us to eat it, because if we eat this sodium nitrate, we are going to have NaNO3. If you eat it, we are going to have sodium nitrite plus oxygen gas. It's possible. This is possible. You know, immediately I saw this, Waec could be very funny. Please note this video, so that you come back to comment that Chemistry Hangout said this thing. A lot of people focused on the second test that is here, which we call the brown ring test. And the brown ring test is them testing for the triazonitrate 5-AO. This is what, see, the people that are asking these questions are professionals, and I tell you, they are professionals. They know that immediately we see this, the first thing that will come to our mind is the common brown ring test that we have. It's possible. Brown ring test is very, very likely, but I tell you, they can be a liver twist, because they know everybody will focus on this. Of course, we are expecting a brown ring test, but I'm still expecting something of this, so that they want to twist the question, because they know everybody will focus on this. I might not even talk about this. So very important, if they ask us to eat, if they ask us to eat the filtrate, so when we eat the filtrate, this will be formed and this gas will be liberated. Can you see? Oxygen gas will be liberated, which means if oxygen gas rather is liberated, number one is that if we test it in litmus paper, it is neutral. That's one. Another one is that it is a colorless and odorless gas. Colorless and odorless. I'm talking about this. That is if they ask us to eat the filtrate, I'm expecting this gas to be liberated, which is oxygen gas. So what are the characteristics? Neutral to litmus paper, colorless and odorless. Then another thing is that it will rekindle a glowing splint. I think let me write it here so that you guys will see it well. So let me first of all remove this. So for oxygen, please help me bring the camera closer so that we can. So for oxygen, note that if they ask us to heat the filtrate, this is the filtrate, sodium nitrate. If they ask us to heat the filtrate, this will be formed. So characteristics of this oxygen gas. Okay, let me write it here. So that characteristics of oxygen gas, number one, it is neutral. That's physical properties. It is neutral to litmus paper. Note that. Number two, it is odorless and tasteless. And number three, it will rekindle. Because what is actually important, or what aids combustion? For anything that is burning, what aids it is oxygen gas. And that's the reason why you see when you are burning something and you begin to fan it, you provide it with oxygen gas and the thing it rekindles. So it rekindles a glowing splint. So that is if they ask us to eat the filtrate. So note that. Please note this and take note of this. If you are asked to eat the filtrate, then we have sodium nitrite, not nitrate, nitrite. I have sodium nitrite and oxygen gas. Okay, so that's one of the tests I'm expecting from the filtrate. Another one I'm expecting from the filtrate is the common one that everybody is actually predicting, which is the brown ring test. Students, please take your time to read all these things too. And the brown ring test is NO3 minus. And how did that happen? We will add freshly prepared iron 2 sulfate plus conc H2SO4, or dilute if you have that dilute. I prefer conc. So you will slant after you have added this to the filtrate, okay? After you have added this iron 2 sulfate to the filtrate, you will now slant the test tube and add the H2SO4, sliding down the test tube. It will form 2 layers, and you will see that ring, at the junction of the aqueous and the acidic layer. You see that ring, and that's where we confirm. That's a confirmatory test actually for triazonitrate 5-ion. So 2 things we are expecting from here is either this or this. The common one is this, but I tell you that you can have this. You can note this and take note. I'm not saying 100% because it's prediction, because they know that everybody will be concentrating on this and we might have forgotten this. But note that in my video when I was analyzing, I talked about this, that oxygen gas can be liberated from the what? From the filtrate, which is sodium nitrate. Oxygen gas can be liberated. Why? We can test for oxygen gas here. We can also test for triazonitrate 5. I want to believe this is clear. Let me wrap up this place. So we talk about the rest of the video. I want to believe this is clear. So take note of that. And how do you know as students? See, that's why you have to be smart. Videos like this are to sharpen your lens as student. Video like this, because if I'm a student and I see on that day that they say eat the filtrate, I know that oxygen gas must be liberated, and I already know what to say in my observation. If they say eat the filtrate plus eat, then in my observation I'll say a colorless, odorless gas. Do you see that in my observation? A colorless, odorless gas is liberated. Is that not? I'm talking about this now. A colorless, odorless gas. A colorless. Sorry, it's not odorless and colorless. Let me use that one. Not tasteless. Who is tasting it? You want to taste the gas? so let me use odorless and colorless, please. It's not tasteless. So. Have you tasted it before? I've not tasted it before. So don't let me put tasteless. Let me put this. So odorless and colorless gas. So immediately I see on that day that they said the filtrate plus it. Do you see that? That's the reason why if you are a very smart student, you can finish your number 2 without doing the test. Because you already know the reagents. The reagents they are telling you to add will tell you what you are testing for. That's why we are doing all this analysis on this channel. So if I see on that day that they said filtrate plus sodium plus filtrate plus heat, we already know the filtrate. This will be the filtrate. So this will be the residue. So immediately I said filtrate plus heat. I already know my observation. My observation will now be an odorless and colorless gas evolve, which is neutral to litmus paper and rekindle a glowing spirit. So what we now write in my inference, oxygen gas is present. I don't know if you are getting that. So that's what I write. But if the question now says the filtrate plus freshly prepared, do you see that? The filtrate plus freshly prepared FeSO4 plus concentrated H2SO4. What will you now write in your observation? The observation will now be that a brown ring is observed. Do you see that? A brown ring is observed. What will now be your inference? NO3 minus confirmed. Because that's a confirmatory test. So these are the two things we are expecting. For me, these are the two things I'm expecting. It's either they are telling us to eat it or we are doing this. So if you are seeing this on that day, you should be able to answer the question. So let's move to the residue now. As we conclude today's live class, let's move to the residue. Oh, this residue is a bit tricky. That's why I had to do it second. I'm expecting for the residue, I'm expecting some Oliver Twist here. I'm expecting a lot of trick from here, but we will catch them. Don't worry, we will catch them. So for this, what are we expecting? Now look at this. The first thing I'm expecting here is that they ask us to add dilute HCl. Or dilute, I'm expecting them, to tell us to have dilute HNO3, and I will explain why. Yes, I'm expecting us to add this. This is the reason. If you add, since this is the residue, if I add H2SO4, please pay attention to this now. If I add H2SO4, I'm going to have PbSO4 plus H2O. Guys, please take note of this. Plus CO2. If I add HCl, I'm going to have PbCl2 plus H2O plus CO2. Guys, just pay attention. But if I add HNO3, I am going to have Pb, okay? I'm going to have PbNO3 plus H2O plus CO2. Please, we have to balance the equation. I don't have enough time, but I still like to balance the equation. I don't like leaving equation unbalanced. So this is lead, balance. This is carbon 1, this is carbon 1, balance. This is 3 oxygen plus 4, that's 7. 4 plus 5 plus 2, that's 7. 2 hydrogen, 2 hydrogen. I think this one is balanced. This clear. That one is balanced. Let's check this one. Lead is 1, chlorine is 2 here. So let's balance this. So let's see now. Lead is 1, balance. Chlorine is 2, balance. Hydrogen is 2, balance. Carbon is 1, balance. Oxygen is 3, 1, balance. Okay, let's check this one. This one now. I just like to balance, but sometimes I can, because of time, I'll just add the equation so that you guys will balance. But I just like to balance the equation. But I might not be doing that because I don't want, the video is already getting too long and I want to quickly conclude. So lead is this, I think that's balanced. Carbon is this, I think that's balanced. 3 oxygen plus 3, that's 6. How many hydrogen? 1. So let me add 2 here because I'm seeing 2. So let's see it again. Lead is 1, balance. Carbon is 1 here, balance. Oxygen is 3 plus 6, that's 9, Abby. Okay, that's balance. Then this 6, 7, 9, balance. Okay, hydrogen is 2, nitrogen is 2. Okay, this is balance. Now, the reason why I said they might first ask us to add this. Look at what I'm saying. If you add this, you will now come back to the salt we started with. Do you see that? Do you see the salt we started with was lead nitrate? And what are we getting here? Lead nitrate. I don't know that. And I already said something. I said the lead nitrate is soluble in water. So if we add this is insoluble because this will be insoluble. This salt too. You know we are looking at the lead salt now. This one will be insoluble too, but this one will be what? Do you see? So the idea here is for us to add this so that it will be soluble, so that we can come back to, I don't know if we are getting the twist here. So we might be asked, that's my prediction anyway. So we might be asked to add HNO3. Please, the reason why I'm writing all this is to give you a clue, which means on that day, if they ask you to add this, you already know that this will be a white precipitate that is insoluble. I don't know if you are getting it. So either they ask you to add this or this, but I'm predicting that we will add this later, and I will show you where we are going to add that. So this is soluble. So if you add this, this will be soluble, okay? And if this is soluble, look at it. CO2 will be formed. This is a gas. This is that. So I can say that if I add this, there is effervescence, because for CO2 there is effervescence. That's for CO2 now. Effervescence. If you have been following my channel, we have even done this. There is a video I did on this that I use lime water. That I turn lime water milk. If you have been following my channel, you will know all these things. So effervescence, a colorless and odorless gas, which turns lime water milk. So if we add any acid you are adding, please note that any acid, any mineral acid you are adding to the residue must liberate CO2 gas, because you see, all will liberate CO2 gas. So take note, if add any of these they ask you to add will liberate, I'm sure they will ask you to add at least 2 or 1 of this, is sure. So anyone you are adding, so immediately I add this and it becomes soluble, this gas will be liberated. I don't know if you get that. So when this gas is liberated, I can record that when you added this, effervescence occur, a colorless and odorless gas which turns lime water milky. Then I can say it is CO2. So I can say CO2 gas from CO3 2 minus. Do you see that? So CO2 gas is liberated from this. I don't know if that is clear. So you can see any carbonate, even if it is HCl that you added, CO2 must be liberated. The same observation. This is the observation, this is the inference. We are still going to do the practical here, but I'm just explaining so that you know what to expect. So after we have recorded this, we have tested for CO2, so this one is already catered for. Can you see? We have catered for sodium here. Peradventure they ask us to do sodium, it will be flame type. I'm not expecting it. So we have done sodium, we have done for nitrate. 2 things that they can ask us to add. Either we eat the filtrate or we add this. It's clear, right? So for this one now, we have catered for the CO3, which will liberate for every mineral acid added to the residue, it will always liberate CO2. Do you see? So what are we left with? Do you see that now? That's what. So let's deal with this now. So after we have added this, this is a clear solution. This is a clear solution because I already said it's soluble. I don't know if you are getting that. So this is a clear solution. So if this is a clear solution or a colorless solution, because if we add this now, it will dissolve this. So this will be a colorless solution. Observe with effervescence, odorless, and so the colorless solution is from this one that dissolved this, while the CO2 is from the CO3, the gas liberated. So it will now be left with this. They will now ask us to take this one now and divide into 2 or 3. Because this one is a clear solution now, it is colorless already. So they will now say, from the solution of this, divide it into 3. So let's divide it into 3. First portion, what will happen? They will now say, okay, for the first portion, add sodium hydroxide. I don't know if we are together. So for the first portion, if you add sodium, you divided this one into 3 now. So for the first portion, we are adding sodium hydroxide. When you add sodium hydroxide to this one, what will happen? You are going to see a white, chalky precipitate. Please take note of this. A white, chalky precipitate. When you now put it in excess, when you put sodium hydroxide in excess, it will now be soluble in excess sodium hydroxide. I've given a lot of clip. In fact, if I did not do the practical, somebody say, you must do it. Even if I did not do the practical, you should get A1 with all this analysis. This is a 90% analysis that I'm sure of. I'm telling you, this 90% analysis that I'm sure of. So when we add first portion, we add this. Now look at it to understand the student. We are working with the what now? With the residue. So on that day, if I see the residue, they ask me to add sodium hydroxide. This is what will be formed, it's sure. So that's white chalky precipitate. So this will be the observation. Do you get that? So the inference will now be, if a white chalky precipitate is formed, what are we expecting? We are expecting this or this to be what? To be present. Some people will go and write aluminium. Aluminium is not chalky precipitate. Aluminium is a white gelatinous precipitate. But for calcium too is used to form white chalky precipitate in sodium hydroxide. Do you see that now? Calcium. So if I have white precipitate in sodium hydroxide, please note it. In sodium hydroxide, white chalky precipitate will give me calcium 2 plus, lead 2 plus present. When I now add sodium hydroxide in excess, it will be soluble. So if it is soluble now, I can now say this is what? I want to believe somebody is following me here. So on that day, anytime they ask you to add residue to sodium hydroxide, it will have white chalky. It will get teachers too to understand the test to carry and how to do all those things. So calcium and lead is present. Aluminium is white gelatinous, not chalky. Some people used to get it confused, but aluminium is actually white gelatinous present. It is these two that are chalky. Okay, chalky means like chalk now, as if you grounded chalk, you now put it in water. Okay, so but if you add excess sodium hydroxide, it will dissolve. So this will be only lead will be present. I don't know if you get that, because for calcium will still be insoluble. Do you get that? But now, since it's soluble, you have left calcium from the test. You are now, that's number one. Number two, if they ask you to add ammonia solution, do you see that? Which I am sure they will ask you. Sodium hydroxide and ammonia is sure for the residue. It's sure. That's the normal thing they will have. So if they ask you to add ammonia, what will happen? You will still have a chalky precipitate. I want to believe this is clear. You will still have a chalky precipitate. So you can still record. That's if there are anyone they ask you to ask you. This and this is still present. But if you add this one again in excess, it will still be insoluble. Don't forget, if you add it in excess for sodium hydroxide, it will be soluble. But in ammonia, it will form chalky precipitate in drop. This one is white chalky precipitate in drop. This will be present. These two will be present. But if you add it in excess, if you now have the sodium hydroxide in excess, it will be what? It will be soluble. Then only lead 2 ion is there. But for ammonia, if you add ammonia, you have chalky precipitate. This and this, Abi, is present. Do you get that? Or you can say, but aluminum is not chalky anyway, it's gelatinous. So you can say this and this is present. So if you add ammonia in what? In excess again, it will not still dissolve, it will be insoluble. Then I can say this is what is present. So can you see that we have successfully been able to test for lead? We have confirmed lead here because lead is one that is soluble in excess sodium hydroxide. So we know lead is present here. We have confirmed with ammonia again that lead is present here, which means we have catered for all the tests. We have tested for lead. We have tested for CO3 2 minus because this is what is present. We have tested for nitrate ion. You see that we have tested for nitrate ion and we have tested for sodium. That's the flame test. But I'm not expecting that, but that is it. So, but if we are asked, which is the last one now, if they now ask you to add, for the residue now, we started from them telling us to add this, we get this, then into 3. I told you 2 or 3. So in the third one, they might not ask you to add this. The first one was, we added, after we collected 3 samples from here, we added sodium hydroxide, we added ammonia. They cannot ask you to now add this HCl. Why? Why did they tell you to add that HCl? The reason is because that's one of the things we use to differentiate this from actually this. So when you add this, have I not said that it will be insoluble, white precipitate? Now take note, which I am sure they will ask you. If they ask you to add dilute HCl, which is the last one now, what will happen? This salt will be formed. PbCl2. And how do you know? It will now be, the observation will now be white precipitate that dissolves on heating and reappear. I'm giving you hint on what? So if they ask you to add HCl, this is the observation we are expecting. White precipitates that dissolves on what? Heating and reappears on cooling. Why? Our inference will now be Pb2 plus also what? Present. That's one of the tests to differentiate this from this. This will not form this. So note that they have to add sodium hydroxide in drop. You are going to have these two present. They have to add it in essence. You have only lead to be present. We are talking about the residue now. Why they ask you to add the residue, sodium hydroxide, lead is what? Is present. In SS2, it will not dissolve, it's insoluble. Lead is present. I want to believe that is clear. If they now ask you that the residue, you should add dilute HCl. So what happens? If they ask you to add dilute HCl, what will happen? You are going to have a white precipitate. And that white precipitate will dissolve on heating and reappear on cooling. I want to believe, I have done an 85%, I am sure, 85% of this thing. You can, please take note of this video that I'm doing, so that you can check the question on that day. And you will see, you will see that it's not like we are guessing, like we don't know what will come out. As we are seeing the instruction, we can actually have, graphs of what we know is going to come out, because the instruction has been given. So we have this belief of this analysis. So take note of this analysis. I'm giving you a 75% assurance of this analysis that I've done. Yes, these are what we expect on that day. Note this, watch this video over and over again. Very important. And I've told you, for the reagents you are going to buy, you can see that for the test that I use, you are going to be needing sodium hydroxide, you are going to be needing what? Ammonia, right? And you are going to be needing HCl. Do you see that? And you might be needing H2SO42. You might be needing Fe. So these are the ones you prepare. Not that you just go and buy all the reagents, you waste your money. So these are just the analysis of 2024 chemistry practical. Don't forget, we are still coming out with our video on this so that we can do it practically. You know us on this channel that after we have talked about the theory, we now show you practically so that it will build your confidence. But these are all what you are expecting. I've told you I have my lead nitrate already. I have my sodium carbonate already. I would have done that, but I have to prepare sodium hydroxide that I need. So sodium hydroxide, I have to prepare ammonia that I need for the test. You get that now? So we are going to carry out that, and we'll now bring, the way I used to predict my question. I'll now give you sequentially. You understand now? I'll give you sequentially of what to expect. But this is 75% to 80% correct of what to expect from 2024. Please, if you are a teacher and you are still finding preparation of laboratory reagents very difficult, please kindly reach out to me. Please, you can reach out to me so that the aim is for us to lead these students to success. The battle is not against chemistry teacher. It's not against who knows it well. It is just to aid ourselves. The people that have spoken to me personally, or people that have reached me via my channel. So the aim is to actually aid ourselves, teachers and students inclusive. The aim is to make us better. The aim is to, if you look at even how much we are still striving, look at a whole lot of failures recorded by students in JAM. It's deserting. That's why we have to just do all our best to make sure these students pass, do videos, analyze all this, and make sure we actually lead them to success. So I have created a WhatsApp group. Check the comment box section. I have created a WhatsApp group for all Waec students, science students now. So if you are writing Waec 2024 and you are a science student, check the link in the comment box section. Click the link, it's going to take you to the WhatsApp class, the WhatsApp channel that I've created. This is not only about chemistry, so that when the physics practical comes to, we can guide you. This is what to do, the biology, we can guide you, you understand? So we can guide you and make sure that you actually come out in flying colors. So check the comment link. And I've noticed something again about students. Please, this is not your school that you are doing first to carry first position. When you see an educational link like this, share it with your friends. I believe you are not the only one in your class. So you are supposed to share this video for them to help them, not holding the video to yourself because you want to show them that you are better than them. No, that's not the aim. So the WhatsApp link is in the comment box section. Immediately you join the WhatsApp link, send it to your friend too. Let your friend join. Send you that they have sent it to, send it to people so that they can join, so that your people will benefit. Seeing everybody do well is our aim here. Okay, so check the comment box section. Okay, you are going to see the WhatsApp link. We have created that. Please, the link is not for examination malpractice. So if you know you are into examination malpractice or you are waiting for us to give you answers, then don't join the link. The link is to aid you, give you questions. Aside from this, predict questions, send it to the group, you solve it, you ask questions, you interact with a lot of students and a lot of people. That's what the link is for. It's not to give you answers on the day of the exam. We cannot be stressing ourselves like this, analyzing all these practicals, buying reagents. I'm still going to come to my YouTube channel to still do the video of the practical. So nobody is giving you any answer on the day of the exam. We have to guide you before the exam, and that's why we are doing this. So send this video to your friends, tell them to join the link in the comment box section. Okay, it will take you to the WhatsApp link. Then we start to advise, to give you orientation, give you questions, and to make you do better. So join the link, check the comment box section, join the link. If you have any question, you can ask me. I'll try to provide answer because I've been busy for some time now. So, but I'll try as much as possible to provide you with the answers in the comment box section. So don't forget, share with your friends. If you are just watching this YouTube channel for the very first time, kindly subscribe to this channel so that you will not miss out on our updates. So share it with your friends, give them the link, let them join, share this video, let them join the link too. And together we can make Nigeria a better place. Together we can make the world a better place. I love you guys. This is Chemistry Hangout, and one of the best YouTube channel as far as chemistry content is concerned. So click on the subscribe button now. Click it now so that you will not miss the video. Click it now. Don't procrastinate. Click it now and share it with your friends. I love you guys. Till we'll be meeting again on this channel. Stay chemically active. Wish you success in your Waec examination and other examination. I love you guys. Thank you.